let's talk about how to use half-angle formulas to help us find the exact value of these trigonometric functions. Now, before I gave you one formula for tangent of theta over 2, I should have given you 3 formulas. There are multiple forms, and the ones that I did not give you are actually much easier than the one that I did give you, so apologies for that. Also remember the quadrants, which trig functions are positive or negative. Now the sine and the cosine formulas, and the one I gave you for tangent from before, says plus or minus. That is not the answer. The answer is not positive or negative. It's only one of them, okay? So you have to figure out, is the answer positive or is the answer negative? Everything is positive in quadrant 1. Sine and cosecant are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. And cosine and secant are positive in quadrant 4. Use the half-angle identities to help you find the exact value of each. Our first step is to find in which quadrant is this original angle, 7 pi over 8. Well, 0 is here, and then we have pi, and then we have 2 pi. Pi can be written as 8 pi over 8. So 7 pi over 8 would be in quadrant 2. Sine is positive in quadrant 2. So now I know, because the angle is in quadrant 2 and I'm taking sine of that angle, my answer will be positive. When they ask you to use half-angle identities, they're taking an angle from the unit circle that you do know the values to, and they're giving you half of that. So you need to know what is the angle that was cut in half in order to use this formula. So we're saying theta over 2 is equal to the angle that they give you, 7 pi over 8. We can see that here. Theta over 2 is the argument for each of these formulas. So now you need to find theta. How do we solve for theta? Let's times both sides by 2. Get theta by itself. Theta is equal to, that is 1 over 4, so 7 pi over 4. This is the angle that you actually know values of. You know stuff from the unit circle for that. So we're going to rewrite sine of 7 pi over 8 as sine of 7 pi over 4 divided by 2. Now, is 7 pi over 4 divided by 2, is that 7 pi over 8? Well, let's just check. 7 pi over 4 divided by 2 is the same as being multiplied by 1/2. So yeah, that is 7 pi over 8. We are correct. Now we're going to plug this into the formula. Okay, the formula states that sine of an angle is plus or minus. We already know that it's positive. It is not the negative option. It can only be one of those options, not both. So square root 1 minus cosine theta. Now theta is not the angle they give you. We had to solve for theta. So theta is twice the angle they give you. Go ahead and plug that in. 7 pi over 4, all divided by 2. Square root. So let's evaluate. What is cosine of 7 pi over 4? Cosine of 7 pi over 4 is the x value at 7 pi over 4, which is positive root 2 over 2. So we have 1 minus root 2 over 2, all divided by 2. Everything after this is algebra. It's just algebra, but it is somewhat annoying algebra when we have radicals and fractions and combinations of those. So the first step is to combine the two pieces that are in the numerator. Square root, I'm going to write 1 as 2 over 2. 2 over 2 minus square root over 2, all divided by 2. Now I can write the numerator as one fraction, 2 minus root 2, all over 2, all over 2. Continue. I have a fraction divided by, I'll put this as 2 over 1, so a fraction divided by a fraction. So I can rewrite those next to each other. I'll write 2 minus root 2 over 2 times the reciprocal of the denominator, which is 1/2. Okay, when you multiply fractions, you multiply straight across. Numerator times numerator, denominator times denominator. 2 minus root 2 over 4. Still can't have a square root in the denominator, and this one dips down to the denominator, but fortunately we have a perfect square in the denominator. So go ahead and split the radical, 2 minus root 2 over root 4, and then of course now we can simplify. I know it looks ugly to have a root under a root, but that is okay. Over 2, and remember the answer to this was positive, so that is our expression. Let's try another one. Cosine of 17 pi over 12. The first thing is to find out the quadrant. Where is 17 pi over 12? Well, this is 0 and this is pi. So this would be 12 pi over 12. This would be 24 pi over 12. What's halfway between 12 and 24? So I can kind of place this. Halfway between 12 and 24 is just 6 units away from each, so that's 18 pi over 12. Okay, that gives me a picture. So 17 pi over 12 is in quadrant 3. Is cosine positive or negative in quadrant 3? Cosine is only tangent and cotangent are positive in quadrant 3, so cosine is negative. Okay, now we need to know how to write this angle. We're going to say cosine of something over 2 is equal to cosine of 17 pi over 12. So we will write the equation theta over 2 is equal to 17 pi over 12. The angle they give you is not theta. You need to find theta. Times by 2 on both sides. Theta is equal to 17 pi over 6. Pi over 6. I'm not very familiar with that. I would like to know 17 pi over 6 as an angle that's actually on the unit circle. An alternate value for theta would be a coterminal angle. 17 pi over 6 minus 2 pi should give me a coterminal angle. We need to have common denominators to subtract, so over 6, this is 2 pi, so 12 pi over 6. Theta is equal to 5 pi over 6. I understand that if you put 5 pi over 6 over 2, you're not going to get 17 pi over 12. So it feels like it's not correct. But the actual values of at that angle are the exact same, because 5 pi 6 will give you all the same trig values as 17 pi over 6 because it's in the exact same spot. So I will write this now as 5 pi over 6 over 2. This will give me the same exact value as if I plugged in 17 pi over 6 over 2. But 5 pi over 6 is easier. So now I plug it into the formula. I know that I need to use the negative version of this formula because my original angle that they gave me was in quadrant 3 and cosine is negative there. So I'll go ahead and write negative 1 plus cosine theta. Negative 1 plus cosine theta over 2. That is negative 1 plus, what is cosine of 5 pi over 6? The x value is negative root 3 over 2. So negative root 3 over 2, all divided by 2. The rest is algebra. The first step, combine the fractions on the top. 1 is equal to 2 over 2. 2 over 2 minus, so it's plus and negative, so minus root 3 over 2 over 2. Now you're going to have the fraction 2 minus root 3 all over 2 all over 2. You have a fraction divided by a fraction, so we can write them next to each other and multiply by the reciprocal. Negative square root 2 minus root 3 over 2 divided by 2, so times 1/2. Multiply straight across, numerator times numerator, denominator times denominator. 2 minus root 3 times 1 is just 2 minus root 3. 2 times 2 is 4. Now we can separate the radicals. So we have square root of the top over square root of the bottom. And fortunately, the bottom is a perfect square, so I don't need to rationalize. I can just evaluate. What is the square root of 4? That is 2. Tangent. This is where most people run into issues because there are so many options for the tangent formula. My favorite one, however, is this one because it only has one piece in the denominator, and that tends to be easier to work with. I am going to skip using the one with square roots in it altogether, okay? I don't want big fractions and square roots that are even more complicated than the sine and cosine ones. So the formula I'm going to use is 1 minus cosine theta over sine theta. 1 minus cosine theta over sine theta. This is another half-angle formula, okay? Completely okay to use. Now, if we're not going to use the square root one, we don't have a plus or minus option. We don't have to figure out if it's positive or negative. That's embedded into these formulas. So you do not need to figure out the quadrant if you are using this formula or this formula for tangent. Don't need to know if it's positive or negative. This formula will give me the correct answer anyways. Let's find theta. Theta over 2 is what they gave me, 11 pi over 12. So they're always giving you theta over 2, so you need to find what theta is by multiplying both sides by 2. Theta is equal to, that is 1 over 6, so 11 pi over 6. Yay, this is a familiar angle. 11 pi over 6. We don't need to find any coterminal. So tangent of 11 pi over 12 could be rewritten as tangent of the angle 11 pi over 6 dividing 2. Let's plug that in. 1 minus cosine theta over sine theta. 1 minus, what is cosine of 11 pi over 6? Cosine is the x value at 11 pi over 6, so positive root 3 over 2. All over sine of 11 pi over 6, that is the y value, which is negative 1/2. Okay, yay, we don't have a square root, so we don't have to deal with that. We just combine and simplify. So 1 is equal to 2 over 2 minus root 3 over 2 divided by negative 1/2. So I have a fraction on top that's 2 minus root 3 all over 2. That's dividing the fraction negative 1/2. So really it's multiplying the fraction 2 over 1, negative 2 over 1, 2 and 2. 2 over 2 is 1, so you have a negative 1 times this. Negative 1 times 2 minus root 3. Distribute the negative 1, negative 2 plus root 3.